Alright class, right now we are looking at AB44, which is about something called slope fields. Now, slope fields, what is a slope field? A slope field is really just a whole bunch of derivatives kind of all overlapping by taking all the derivatives and kind of all over the place. Let's just jump right into it. So here's a general idea. dy dx equals y. Okay, how do I deal with that? So the derivative is y. So when I look at the derivative, it's going to be equal to y. So when I look at these numbers, let's say that I'm looking at the derivative at negative 3, 3. So that first one would be right here. What's the derivative at this point? Right there. Whoops. Take away those two marks there. What's the derivative at negative 3, 3? Well, at negative 3, 3, it's just y. So it's really just this 3. Well, I don't know, is this x or is this y? Let's call these y's and these x's. And the only reason I'm doing that is because I have x's often go horizontal and y's often go vertical. Okay, so at negative 3 for the x and 3 for the y, that means this is just 3. At negative 2, 3, it's still just 3 because what is it? At dy dx, I'm really looking for the derivative at negative 2 comma 3 like that. Well, it's just 3, and similarly all these are 3. So there we go. And that wasn't too bad. So that means here, the derivative is 3. We'll learn how to draw that in a second. Let's calculate it at y equals 2. So at y equals 2, that's going to be at negative 3, 2, that's 2. At negative 2, 2, that's 2. Why? Because the derivative is y. So this is 2, 2, 2, 2, 2, 2, 2, all the way across. And here's 1, 1, 1, 1, 1, 1, 1, 0, 0, 0, 0, 0, 0, 0, negative 1, 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 negative 2, all the way across, and negative 3. Hopefully you guys were catching on to that pattern as well. So at the point negative 3, 3, which is, oh, that's not even negative 3, 3, that's negative 3, 2. At the point negative 3, 3, which is right here, what's the slope? It's 3, it's positive. So that's kind of like, and it's not just a little positive, it's kind of really positive. Look at this, at 0 down here, these are all 0 slopes. So I just draw these little tiny slope lines, like little tiny slope lines all over the place. Now look at this, y equals 1. That's a slope of 1, which is kind of like 45 degrees. There we go. Whoa, let's keep it a little better. There we go. So there's my slopes that way. And similarly, down on the y equals negative 1, those are going to be a slope of negative 1. So I'm going to draw these slopes at about negative 1. And I know they're not perfect. They really should be, all the same all the way across. Then look at this, y equals 2. So here's y equals 2, right here. Then the slope is about 2. So it's not quite 45 degrees, but it's not quite, slope 3 over 1, but it's somewhere in the middle. And then these 3's, these are super tall, super tall, super tall. Up 3 over 1 kind of tall. Similarly, these kind of start to dip down here. This is more than 45 degrees. And then super steep going downhill. Down 3 over 1. Now again, this is approximate. This is approximate. So there's a bunch of slope. Now I'm going to do some things here. This is asking for two things. One is going to ask for what's the equation through 1, 1. So what I would do is go to the point 1, 1 right here, and I really just kind of follow the direction that flows through that. So if you kind of see this poking out this way, and then once I connect to another line, I'm going to change direction and follow that line. So to follow these kind of blue lines here, where the flow of these lines kind of push me this way, it looks like I would be kind of like that. There we go. Similarly, if I wanted to find the solution going through negative 2, 0, so negative 2 and then 0 would be right here. And I start out flat, and honestly it looks like it just goes straight across, but if I were to curve down, maybe I'd curve down kind of like this. I don't know. There we go. So it's usually just kind of an approximation of curves using information about the derivative. Let's do the same thing over here, but it's going to be a little different. This one, instead of purple, let's use, how about gray? Okay, so at negative 3, so here's my x's. Here's my y's. For negative 3 is x and y is 3. The derivative is 1 over x. So I'm going to use these numbers up here across the top because the derivative uses x. So it's going to be 1 over negative 3, or negative 1/3. Similarly, this next one's going to be negative 1/2. And 1 over negative 1 is negative 1 over 1. Now, negative 1 over 0, that's undefined, but it's undefined in a vertical way. So this is a vertical slope, up and down. Really undefined, which is the same as all these. These are undefined, 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 all the way down. Next, we have 1 over x, in this case is 1. We have positive 1/2 and positive 1/3. Alright, now as we go down in the y directions, notice that y changes but x doesn't, so this is actually still 1 over negative 3, because x is the number that we're using to calculate the derivative. It's right there. We plug in x in the denominator. Similarly, this is going to be negative 1/2, negative 1 over 1, 1 over 1, 1/2, and 1 over 3. So I'm going to have 1/3 go all the way down. Now we have a little bit different relationship. Notice that because x was our calculation, things didn't change vertically as much as they did horizontally. Whereas in example 1, we were looking at stuff that was kind of constant all the way across horizontally. So I got 1/2, 1/2, 1/2, 1/2, 1, 1, 1, 1, 1, 1, negative 1, negative 1, negative 1, negative 1, negative 1, negative 1/2, negative 1/2, negative 1/2, negative 1/2, and negative 1/2. And then the last one's negative 1/3, all the way down. 1 over negative 3, negative 1 over 3. Same thing, getting a little loopy here. There we go. Okay, so we got all these numbers. Oh man, that was a lot. Let's calculate them. I'm going to start with these middle ones because those look a little bit easier to graph. So first, when x equals 0, across the middle here, these are just vertical lines. Kind of hard to see those, but they're just vertical lines right on the axis. When I go to the right at x equals 1, then I hit a 45 degrees. Up 1 over 1. Pretty standard there. Inversely, on the left side, when I go to negative 1, these are a negative decreasing value. So these are a bunch of little mini slopes. Then what happens as we branch out further to the left and right? Well, if we go out further to the right, it's 1/2, so that's kind of shallow. It's not as steep as before. You can start to see the shape coming into play here. And similarly, we have on the other side, but negative, it's not quite as steep as it was. It's a little more shallow in its degree here. And then we get even more shallow, more flat as we go out further, following the same kind of pattern. So there we go. There's our slope fields. Now it's going to ask us some questions about through particular solutions. So let's start with the first one. I'll do it in blue. Through 1, 1. So I'm going to go through this point right here. So again, I'm just going to kind of follow this path, and it looks like that goes there, and then this is going to go down. And there we go. That's the solution through 1, 1. Through negative 2, negative 1. So it's going to be negative 2, negative 1 right here. Again, we're kind of just following this path. And that would be close enough for us to draw in the solution there. All right, so that was it. That's all we really had to do. Let's do it again, though. We're going to do a couple more here. Same idea. We're going to draw the slope fields, calculate them, and then get them from there. All right, so now we got some crazy stuff going on. Is this picture separate? No, it's all together. It's all the same thing. Well, let's deal with it one step at a time. So for the first part, we have negative x over y. So here's our x's. Here's our y's. We need to define that for our table so we know which number's which. When it says negative x over y, that means I'm going to take this number, multiply it by negative, and then divide it by the other number. So that's really positive 3 over 3, or really just 1. This is going to be positive 2 over 3, positive 1 over 3, 0 over 3, or just 0, that's flat, 1 over 3, but this is a negative, it's multiplied by negative x, so this is really negative 1/3, and then 2 is negative 2/3, and 3 is negative 3/3, because you multiply the x by a negative, and then work from there. Now for the next one, it's going to be 3 over 2, so that's 3 halves, and then we got 2 over 2, and then 1 over 2, 0 over 2, and negative 1 over 2, 2 over 2, or negative 2 over 2, pardon me, and negative 3 over 2. So we got this pattern where the last 3 are negative, the first 3 are positive, and the middle one, of course, looks like it's 0 all the way down. So I'm just going to put zeros there. And I notice that these are negative, and the other ones are going to be positive over on the left side. So I'm going to try and shortcut some of the work there. This next one, we're going to have 3 over 1, so it's 3 over 1. Then we have 2 over 1, and 1 over 1. We got the 0. Then we got negative 1 over 1, negative 2 over 1, and negative 3 over 1. All right. Okay, so now let's see what's going to happen. Ooh, this is weird. Divide by 0, because here's the y value, and this is divide by 0. And we can't really divide by 0, so that's undefined. And that's going to happen all the way across here because we're dividing by 0 each time. We have a negative undefined. Check that out. What is that? What is a negative undefined? Remember, undefined slope, or derivative you could say, is really just a vertical line. That's all it is. Because you have a number over 0, which represents your kind of rise and your run, and it's no run, rise only. Rise only, without moving left to right, winds up being a vertical line. Okay, so we got good stuff so far. Let's keep going. Now this next one, we multiply the x by a negative, which makes this 3. But then it's going to be divided by negative 1. Which kind of changes all these numbers here. So these weren't actually negative. And the next one's going to be 2 over negative 1, or just negative 2. And then the next one after that's going to be negative 1 times the negative, which is 1 over negative 1, or just negative 1. So now I have negatives on the left side and positives over there. Okay, so then let's work our way all the way through the left side here. This is going to be negative 3 over 2. And then we got negative 3 over 3. All right, now for the next column, we have negative 2 over 2. And negative 2, whoops, pardon me. Then negative 1 over 2. We got negative 2 over 3 and negative 1 over 3. All right, now we're just going to have the positives on the other side. So this is 1, 2, 3. We have 1 half, 2 halves, 3 halves, 1/3, 2/3, 3/3. All right, so we did all that work. Now let's draw them. Okay, so I noticed first that down the middle, these are all 0. That's going to be easy. Those are all 0. That's a little helpful. What else could I see? Okay, across the horizontal axis, those are all undefined, so those are going to be all vertical. Wait a second, this 0 in the middle, that's not really 0, it's undefined. So let's kind of just leave it empty. There we go. Now let's do some easy ones. I see these 4 here are all a value of 1. We just got to get the negatives and the positives straight. So this is a negative 1 over 1 over here. This is a positive 1 over 1. This is a negative 1. This is a positive 1. All right, so those are out. Did all those. What do I got left? All right, let's do, how about the 1/2? Okay, so we can do 1/2. 1/2 is going to be a shallow, so if I go a little bit higher, this is going to be a little more shallow. And then even more shallow than that after it. Similarly, this is less steep here and then even less steep there. So we can kind of do some symmetry on the other side. There we go. So we're starting to get kind of a directional field here, some slope field action. Now let's do, okay, so these columns are all done. We did the numerator of 1, the denominator of 3. Let's look at the next column. We got 2/3. Let's do the left side. 2/3, 2/2, 2 over 1. So that means 2/3 is kind of a fraction. But then 2/2, that's a 45 degree. And then 2 over 1, that's actually kind of steep. And then we're going to have this, the inverse, the symmetrical opposite of that down here. And then we got 1 over 1 and then 2/3. Now on the other side, we're going to have a similar kind of relationship where the middle ones are 45 degrees, you could say. But then we have a steep here, and then shallow, and shallow. You guys can probably imagine what the next ones are going to be. This is actually going to be 45 degrees, 45 degrees, 45 degrees, 45 degrees on all those. Then we have these other measures. So we're going to have like 3/2. So that's a little more than 1. So that's a little steep, but not super steep. And we have really steep there, and really steep, and then a little steep, and not super steep. There we go. All right, so there's my slope field. Now I just got to draw some pictures. So it's asking me, what's the equation that goes through 1, 1? So if I'm going through 1, 1 right here, this looks a lot like a circle. I would imagine it kind of goes like that. And then if I were to try to figure out what's the solution that goes through -2, 0, so -2, 0 would be right here. That looks very circular too if I kind of follow these lines. It's got that circular flow. So those would be my 2 solutions. So that's a lot of calculations. We are doing, how many calculations did we do there? We did 49 calculations. That's a lot. We're doing them quickly, but that's a lot of calculations. Let's wrap it up with one more here. Okay, so now we have x plus y. So I'm just going to take these two numbers and kind of set them equal, or add them together. So 3 plus -3, that's 0. Wait a second, so these diagonal ones, 2 plus -2, that would be 0. 1 plus -1, that would be 0, then 0, then 0, then 0, then 0. Okay, so that was not too bad there. Let's go across the top. 3 plus -2, that's 1. 3 plus -1, that's 2. Then 3, then 4, then 5, then 6. Okay, that was kind of a pattern. 2 plus -3, well, that's -1. And we got the 0. 2 plus -1, that's 1. 2 plus 0, that's 2. Then 3, then 4, then 5. Ooh, I see a pattern. So next, we're going to have 1 plus -3, that's -2. Now look at this. I can go straight down. -3 plus 0 is going to be -3, -4, -5, -6. Then we're going to have just this long pattern. So hopefully you guys are seeing some of these patterns as well, like I have seen here. And in fact, the diagonals are the same all the way across. That's, kind of interesting. So -3, whoops, -4, -3, -2, -1. We got 1, 1, 1, 1, 1, 2, 2, 2, 2, 3, 3, and 4. There we go. So let's draw those. Let's draw them. Okay, so we got zeros on this diagonal, so that's a flat line. Those are easy to draw. I like to start with the zeros. So I'm going to start with those and draw zeros on this diagonal line. Then if I go to the right, it looks kind of like on the top side here, you could say, those are positive ones. So that's 45 degrees in the positive slope. And those should all be about the same. Try to aim for about 45 degrees there. We know that we're doing an approximation here, but we can get it pretty close. And similarly, -1 on the other side. So that's going to be 45 degrees, but in a decreasing manner. So there we go. That's that side. Now, if we were to keep going, we get more positive the further we go to the right, to the point where when we're here at 3, 3, that's kind of like super, almost vertical. So we get more positive, then more positive, then more positive, then more positive. So we have this kind of increasing positivity here. So there we go. That's kind of what this looks like. We get more positive, more positive. So we're just kind of sketching that, but hopefully it has a decent flow. Similarly, these numbers get more negative the further they get away from that diagonal line in the middle. So this is super negative all the way here. Then we get not quite so negative as we get closer. So we have all these decreasing slopes here. Excellent. Close enough. So now we're looking at some solutions, I think, right below this. Find the solution that goes through 1, 1. Okay, so the slope at 1, 1 is right here, and it's 45 degrees. And then if I were to kind of continue through that, it looks like I get super high once I move to the right. And I flatten out here in the middle, about. But then it looks like I start to follow this line there. So it's almost like a parabola, but not exactly. So there's our blue one. So let's look at what goes through. So that was blue. That was part A. Part B, I'm going to see what goes through -2, -1. So -2, -1 starts here. So I'm going to extend this line, kind of start to connect the dots. And as I go further to the left, I get more and more negative. Which means I still have this kind of curve that's going to eventually flatten out down here and then come back up. There we go. Those look pretty good for approximations. Okay, so what's the general idea? How are we doing all this? First, make a table. Just get all your values. Table, that's one. Second thing, what are we looking at? Draw. Let's call these micro slopes, because they're little tiny slopes that only last for a little piece. Then 3, connect the dots for specific solutions. And there we go. That's it. All right, so let's go ahead and stop this here, and we will see you in the next video.